Welcome to Z-Tech Almanac. This is the second video I'm doing in the series of restoring the Macintosh Performa 460 computer and all the peripherals. We've seen in a previous video that we went through and restored the keyboard and the mouse and the microphone. So in this video, we'll look at restoring this monitor. This is an Apple Performa Plus Display, and as you can see, there's quite a bit of yellowing on the sides here. There's this spot, especially as you turn it around a little bit, you can tell that there's not only dirt, which we'll clean up here in a sec, but also the yellowing. So we'll go through the plastic whitening procedure that I've used before, and the challenge there will be is getting enough liquid to cover all this the monitor, because it's an odd shape. It's not a flat shape as the keyboard was. And then of course we'll look at the electronics inside, replace any electrolytic capacitors, and we'll also discuss safety. This being a very high voltage device with the Crt Tube, safety is critical here. Even if this wasn't plugged in for years and years and years, we want to discharge any capacitors and the tube itself before we start working inside. So anyway, the first thing that I'm gonna start doing is a very simple procedure, which is take some alcohol and then start wiping the dirt off. And I'm just using standard 91% alcohol, so pretty strong stuff, so the stuff you buy at the store, to really get some of this dirt off. And I'll go through meticulously through the whole plastic case, and the wiring as well. So the cabling looks pretty good, but I'll wipe everything off. So you already can tell that there's so much dirt just by 2 seconds of wiping here. So that's the first step here, and then we'll take it apart and we'll see what's inside. All right, well, let's get started. Okay, so I'm done with the first pass of wiping with the alcoholic wipe, and most of the monitor actually wiped. The dirt came off pretty nicely. I did have to use this magic eraser sheet here that you can tell actually took off quite a bit more dirt in sort of tough to get areas. There was a couple of stains there that just wouldn't come off, so I used this one to take that off. But it looks pretty clean. I'll probably do another pass before I put it in the whitening liquid here for the hydrogen peroxide. Before the hydrogen peroxide, I don't want the hydrogen peroxide to be full of dust and dirt and everything like that. So yeah, but it cleaned up pretty nicely. Obviously it's not white, but you can tell that I took the bottom apart for the stand. It has these two pieces, so this is the very bottom, and then this thing kind of comes like that, and there's some more dirt in there to wipe off. And that's nice because I can actually put these in the hydrogen peroxide individually, and they'll be fine. They can whiten on them by themselves. So anyway, so that's the first pass of sort of wiping, and next I'm gonna take it apart and see what else needs to be. The idea is that I'm gonna take all the plastic pieces off. So in the process I'll be taking lots of pictures. Make sure I can actually put this back together when it's all said and done. To start taking it apart, just want to undo these screws. They're kind of long in there, so use a screwdriver that's long enough. And there's 4 of them, looks like. I haven't taken this apart before, so it looks like there's 4 just on 2 sides, 2 screws on the top and 2 on the bottom. And hopefully that should do it to pop this off there. So with those 4 screws out, I'm hoping here that I can just start taking the back off. It just kind of comes off like that. And see things are falling all over the place. You can see the insides here. Hopefully that's visible there. All right, let me shine some light here, and just to see the insides a little bit better. So we got the CRT tube that we need to discharge. So before even touching anything here, as I said, we need to look at some of the bigger capacitors like this one. Has to be discharged just to make sure. And the way I discharge it is just short it with the screwdriver. You know, these capacitors is not going to hold much charge since it hasn't been on for a while. But, you know, if your monitor has been on recently, like in that last hour or so, it's best to just discharge it with a discharge resistor, you know, 1 kilo ohm or so across the terminals. Obviously isolated, you know, and then just hold that there for a couple seconds. And then, yeah, so what we'll be looking at is, take this further apart a little bit here, but we're looking at, you know, capacitors like these to, you know, recap, so change out. And then we'll look at the fuse, make sure that's good. Looks like it is, but we'll double check that. And, you know, we'll look for other signs of burn or damage, you know, from transistors or resistors that might have burned up. I don't see any right now, but we'll have to take a look and see, right? So go through with the fine-tooth comb on everything, at least visually initially, and then we'll do a power test and see if it works. Okay, so let's discharge the tube, which is the most important part. Now, modern CRTs do have a bleeder resistor on the tube, so unlikely, you know, there's gonna be a problem. But you know, if that resistor's gone, then you know, you'll be in trouble. So what I use is just a flathead screwdriver, and I basically hold it. I will hold it by the end, but which is connected, and I'll connect the screwdriver to the wire to ground in the chassis. And you know this is ground because we got the two green screws, green wires, plus I measured the connectivity of this to the ground lead on the power plug. So there you go, we'll put that there. I'll hold this in my right hand, right there, and my left hand goes behind my back. And all I do is I'll just get in there and then try to touch the just the leads there, just to make sure that it's touching well, and that's all. I can see it touching good. That's all that needs to be done. And that's it. You know, important left hand behind your back. You don't want to be using your left hand to touch anything else, either ground or monitor or anything else. That's just important. Always use the right hand here, and there it is. So before I get to the capacitors, I need to find a way to take the PCB out, so the main PCB here. And I noticed that it's attached with this sort of plastic snap-in. And before I do that, I disconnect a couple of wires on the other side, but not everything, in hopes of being able to sort of gently pull the PCB out without having to disconnect absolutely everything, especially from the CRT. So I'm trying to save, so this upper PCB is directly attached to the tube itself, and I'm at least trying for now to keep that attached because it's zip tied on there with some funky zip tie that is kind of going around the tube, and then it's kind of holding it in there. And I don't have that replacement zip tie really. It's like a two zip tie ends kind of going through on the same zip tie. So I'm gonna try to at least leave it in there and see what happens. So yeah, that's where we're at right now, and you know, after that, time to discharge capacitors and change capacitors. I'm going to try to change all of them if possible, but I may or may not be able to get to every single electrolytic in here. But this is a tricky part here because I haven't gone through and discharged the capacitors, so I'm being really careful to, you know, touch the ground only and the edges of the PCB, just so I don't touch, you know, accidentally across the leads of a large capacitor. Okay, so that plastic snap-in thing snapped up pretty easily, so I flipped the monitor right side up here. I've disconnected wires that I could find that are holding the PCB to the CRT here, and I've also unscrewed here. There's a holder thing for the main VGA cable. So the whole goal is to slide this out, and you know, it's looking pretty good. So basically we want to keep this PCB on the tube and then slide so the main PCB out. And there's a ground wire here that you'll have to disconnect, and that looks like it's, so it just comes out just like that, right? So now we're quote unquote home free here, being able to, you know, work on that PCB independently. I have to be careful, obviously, with all the wires. Some of them are still connected, like this one. You don't want to be tugging on that. And there's that wire here, this one here that is still connected. So, but all in all, not too bad. And, you know, best case, I see all these electrolytics here, and, you know, all those guys there that can be now easily changed after discharging, of course. Took off the contrast and brightness knobs. I just want to show you something. See how dirty they are. They're like, they have a yellowing part, so the dirty part here, and the part that was inside the case kind of stayed somewhat okay. But you know, it's just kind of funny to see, you know, this little yellow area here, and the rest of it being, you know, whiter. So yeah, those are nice that they can come off, and they'll go in the whitening bath as well, separately. The other thing I found is that, funny thing is that the VGA on the connector here, if you kind of rotate these knobs, there's one side that's yellower. I don't know if you can see that any better here. And that too, I'll take it off and put it in the whitening bath. But the whole plug itself hasn't yellowed. So it looks like only this plastic, which is the sort of screw-in connector, is the one that had yellowed. So interesting, yeah. Not all plastics yellow, and you know, like for example, there's other plastics inside this monitor, and they're just as white as I'm sure they were when they were new. So, all right, so I've completed discharging the capacitors. As I said, just touching a screwdriver to the leads on the back of the PCB. And the next thing that I want to do, and this is just to time all my processes here, is to take out the CRT out of the plastic case, because I like to start whitening the plastic. You know, that'll take some time, and in the meantime, I can order the capacitors to be replaced. So, you know, while waiting for shipping, the plastic is whitening. So I'm kind of, you know, making this not last as long as it usually does. So anyway, to take out the CRT, there's four screws. There's one there, and two on the other side, and that's it. There's some wires and things like that to be mindful of, but you know, especially when putting back together. So good idea to take a picture at this point of the CRT and how it's assembled before taking it out. Once the CRT tube is removed, the case is almost empty, except for this degaussing wire here, this black wire here, that needs to be taken out. And so that's just the last piece. And you want to note how this went in, because the blue connector on that end needs to plug back into the PCB. So you want to take a note that it went in this way. And you know, many people ask, you know, what is this for? It's really to remove any permanent magnetic fields from the CRT tube itself. And it just basically demagnetizes it constantly. And this helped, you know, children like myself when I was younger to take magnets and try to stretch the CRT image. And if this thing wasn't in there, that stretch would have been permanent, or at least semi-permanent. And you would end up with a CRT that has all kinds of squished and squashed image, with the permanent magnetic field being, you know, magnetized, you know, kind of pulling the electron beam left and right. So this helps prevent that, and they probably put it back in the day, and they started seeing children or adults, you know, magnetizing the CRT and the image being all stretched and squeezed. Anyway, so with this out of the way, now we have a clean case. So this can now actually be, I'm going to clean it inside as well, and then the whitening process can begin on this as well. So this is not ready to be whitened. You know, I might take off things like, I see a little sticker there, so take that off and then put it back on if I can. If not, I'll just leave it. You know, at this point, you know, if some of those stickers fall off, they'll fall off. But I'll try to preserve as many stickers as I can, so that can nicely put back on there. So, okay, let me show you how to remove caps with the desoldering tool. I have this tool right here that I'm using. I don't know how visible it is. That basically it's a pump that sucks the solder out. So I'm going to take one of these capacitors out, and the way I'll do it, I'll just get in there and try to melt the solder first. It's the first thing. Try to go around the camera here with 2 hands and just sort of, once you melt the solder, you can just suck it away. And do that a little bit until it fully get it out of there, right? If you can stick this on the lead, that's fine. If not, then just go like that. So once you're done with that, then you can just pull the capacitor out on the other side. There's no need to use a soldering iron until all the solder is removed, and it leaves a nice hole there. So you can just put the new one back in. So that makes it really easy, and you won't destroy the PCB this way. To widen the plastic, I put them in the hydrogen peroxide solution here in this plastic bin. And I have to put some weights on top just to hold them down, because these monitor stands have holes on the bottom, so air just gets trapped in there and will just float. So what I put in here is the monitor stand, the 2 VGA screws, and the brightness and contrast controls. And I've done this before, where in the previous video I showed you that it took a couple of days for it to whiten just on its own, but with the UV light it seems to be a little faster, so I'll do the UV light on it, and just to speed up the process a little bit. But otherwise, if you don't have a UV light, just leave it for days, and it'll be fine. It will whiten up. Here's the UV light. Doing it on here. And I basically, it's an LED UV light, and basically just have it over just one of the the bottom half of the monitor stand first, and I'll move it over to the sort of the top half to get some even lighting, and we'll move things around in there every once in a while just to slush things around and get even lighting and everything. So I don't have a huge UV light, so just have one of these. Maybe it's time to get another one to get even more even lighting, but this will do for now. So I'll leave this on here, probably the UV light, probably a day or so, just for good measure, just to whiten everything up, and then we'll take a look and see how it looks. Alright, so it has been about a day that this has been sitting in there, maybe about, I'd say 10 hours of UV lighting, so I shortened the process down quite a bit from 3 or 4 days that I had it in there before for the keyboard. And everything looks really good. If I look at this bottom of the screen there, this monitor stand, it looks really, really bright, really white, and I'm actually really pleased with the outcome here. So yeah, so I think I'm gonna call this done, and next we're gonna put the actual case of the monitor in here with obviously a lot more hydrogen peroxide, of course, and see how that's gonna turn out. That's quite a bit more yellow than this, so I expect that that's gonna have to stay here for a lot longer and a lot more UV lighting to get it as white as this. But yeah, looks very nice. Alright, next I have the front cover, plastic cover, in the hydrogen peroxide bath here. The bubbles are due to the fact that I'm using a high concentration hydrogen peroxide cleaner, and that has some other cleaning agents in it. So, that's good because it's going to clean up the last piece of dirt and dust and muck off the plastic. So, kill 2 birds with 2 stones here. And I have the UV light shining right on the top of the screen, or the cover, because that was the yellowest part. So I'm hoping that to really shine a whole bunch of light there to whiten it up the most. And the bottom is sticking out. I might flip it over, but really the bottom hasn't yellowed at all. So unless I see like a clear line for me, I'll probably just leave it. But if not, then I'll have that soak in a bath as well. So I'll flip it over in a day or two. So again, I'm going to leave this here for about a day or two, and then next put in the back cover of the screen. And that is really yellow, so that's going to probably stay there for a couple of days, and so hopefully all that yellowness will go away. There's quite a bit of yellowness on that one, so I'm gonna have to leave that there for much longer. So. Okay, so it's time to solder the new capacitors back in. I'm just showing you here how I kind of keep track of where everything is. In addition to taking pictures of the circuit board, but basically I just draw simple drawing here, and I basically put down what capacitor I want, what the voltage is. And I also added what's the lead spacing, because some of these older capacitors, even if you get the same value, you don't want the lead spacing to be way off, because they might stick off the board or have to do unnatural things to get them to fit. So as much as humanly possible, I will make sure the lead spacing is exactly the same as it was before. Of course, some of the smaller capacitors, it's hard to get 5mm lead spacing, so have to maybe work with 2.5mm, and that's fine for the really tiny ones. There is one special capacitor. It's a 6.8 microfarad 50 volt non-polarized, and so this thing looked like this in the original one. Looked like this, 6.8 50 volts. And these were in style back in the early days, back in the 90s. It looks like an electrolytic, but it isn't. It's a non-polarized electrolytic. And these are, I couldn't find them anywhere. They're not, you can't find them. But really the point is that you don't need that capacitor to be exactly electrolytic, non-polarized. And so I went back and forth. Should I use it ceramic or a film? And I settled on a film because the film is more temperature stable, so the capacitor doesn't vary as much. And film is just a longer lasting, better capacitor overall. So I'm going to replace it with this film capacitor here. Now, of course, the lead spacing is not the same by any stretch of the imagination, so I have to do a little bit of twisting and turning and shaping of those leads to make this guy fit in there nicely with that. But this is the only exception with the leads not matching. Everything else matches exactly or very, very close for the small capacitors. Other than that, there's not much to it as far as soldering. The circuit board is on kind of vertical on the side, so in this case I kind of watch that I don't put too much solder on there so it doesn't rip off. But I do like more solder than less solder. More solder, especially in analog high heat circuits like these, is always a good idea. Solder kind of ages over time, and heat makes it a little more more possible for it to break off or fracture, right? So having a tiny bit more solder helps with that. So I don't shy away from the amount of solder, but in this case, I don't want things to be dripping and shorting out something, down on the board. So, okay, well, I'm going to get to replacing all the caps, and then we'll take a look how everything looks, and then finally how everything works, of course. And magically, the board is filled with capacitors. And finally, it's done. Wasn't an easy job. Lots of the problem is this board doesn't sit straight up or down. It's a weird angle with the cables still kind of connected. So I was kind of leaning over and trying to get in there, and it's just not an easy way to go about soldering in new capacitors. But anyway, one of the things I want to show you is, most new capacitors can be smaller than the old ones because technology has improved and all that. That's not actually the case. So the size of the capacitor depends on the voltage, capacitance, and how good it is. I mean, how many hours can it sustain at what temperature? So if you're seeing a new capacitor that is seemingly smaller than an old one, it means that it may not last as long, right? And so all the new electronics today have these tiny capacitors, surface mount, whatever. They're meant to last a year, maybe 2 years, and that's it, right? So they're small for a reason. They're not necessarily the technology being evolved so much that the capacitors now have shrunk. Here's an example. So this is right here a 220 microfarad 200 volt capacitor. This is the new one, obviously, in there. It's a really good Nichicon capacitor. 5,000 hours, 105 Celsius. Here's the old one. Quite a bit smaller. I mean, not as tall as the new one. So maybe about, I don't know, quarter inch shorter, the old one. So the new one in this case is bigger, likely because the old one just wasn't rated for that high amount of hours. In fact, I might even be able to tell what's it rated for. Let's see. I can't. It's not on my case. But, you know, that's just an example of a really good capacitor. Might be bigger. And that's okay. In this case, it will fit. So I'm not too worried about it. But, you know, that's just one example there. Okay, so the next thing is that I will, before starting to put the wires back in, there's 3 sort of knobs here. So 2 potentiometers and the on-off button. So I'm gonna just spray this WD-40 contact cleaner on there, and just get some of that in there, and just make sure the contacts are clean. And same thing here, just kind of freely spray it in that switch. You know, you don't want any residue there. And then, you know, rotating these all the way around and try the switch a couple of times. So yeah, so that will do it for the board. So now comes the part of put everything back together. I want to show you one more thing that happened during this assembly. Hopefully it's visible. There's these little magnets here. There's one there, there's one there. And they kind of fell off. You know, because this little glue kind of crystallized and kind of snapped off and just fell off on its own. Anyway, I think what those magnets are for is to stretch the picture nice and cleanly to a square picture on the corners, because they all align with the corners of the tube. Which is all great and fine, except since they fell off, I don't know which way they go back. So it's going to be a little bit of trial and error, which I'm going to put a tiny bit of glue on there and check out, you know, put this all back together and really test, see what the picture looks like. And then if I have to move it, then I'll snap it off and move it and flip it around, you know, with the poles and everything to clean up the picture on the corners. I don't know how much of a difference they're gonna make. We might have a little bit of rounded corner picture, which may or may not be noticeable. Sometimes it is, sometimes it isn't. But I know those are there for the sort of fine, really sharp square corner adjustment of the picture. So anyway, now I have to do that as well. So that's going to be a fun project on its own when we're going to hook all this up together. And I need the computer, of course, for that and to put out a signal. So, you know, that this is likely going to happen a little bit later. Well, look at that. I was putting things together. I noticed that there's some capacitors there. And put a little light here. You know, these 2 capacitors that I missed. And at least those, there might be some more on this board, which I really was hoping not to have to take off and disassemble, but it looks like I will have to. Well, one of the challenges of the board is it has this shield on the back, which is soldered on. So, you know, I'll have to desolder that. We'll take it off first and desolder the shield. Get those capacitors changed as well. At least those 2 on this side. There might be more underneath the shield that I don't even see. And just to make sure everything's completely recapped here. You know, I could run the risk of just leaving them on, but you know, since I've gone this far to recap this monitor, I might as well do it 100%. So you know, definitely don't want to leave those capacitors there. You know, they might work for a year or 2, or 2 years, or 5 years, or you know, maybe even 10 years. But you know, when those go, who knows? It might take the tube out with it, or you know, you never know, right? They could short, they could leak, electrically leak. I mean, or physically, right? So might as well take the effort now to, remove all that stuff. So to take this back plate off now, the thing that I've done here just quickly is to cut the white zip ties. It's kind of hard to see. There's two zip ties there. And kind of go around and kind of hold this in place. The zip ties go around this. There's a metal bracket that goes around the tube, and it's screwed in there underneath that. So I'm gonna avoid taking it off for now. And then one of the things I want to avoid is messing mechanically or physically with the tube itself. Just want to avoid all that. So when I put this back on, I think probably the best and safest thing will be to just don't even use the zip ties if I can get it in there, and then just slide it back on, because the tube pins are very strong, so they'll hold this whole thing. So the zip ties are just there for really just tamper proofing, not so much of having that much pressure. They're not even all that tight. They're just sort of there to kind of hold this kind of in place. So if everything's right, just gently, this thing should come out just like that. So that's that, and the zip ties are just hanging there, so right here. So we'll maybe cut those off, and we'll see if I can put it back on without them, or maybe just use just a single zip tie, not this sort of double. There's two of them on both sides, not this sort of double zip tie shenanigans here. So okay, so now that the plate is off, the board is off, I'm going to have to use my desoldering gun to remove the solder from areas like these. So there's solder there. And luckily it's just soldered on one end. So it's a single-sided PCB, looks like. So I'll just have to desolder from this end. And then I should be able to pull the board off. There's obviously some connectors connected on right here, so those will have to come off. But looks like if I do that, I should be able to pull the board off and then start scavenging for capacitors. I think I saw 4. There might be more, so good thing I took it off, and because we'll do need to change those capacitors. So good thing I did. Everything's hiding behind that shield, so it's always something to remember, where to look under aluminum shields and metal shields for components. So with the shield off, I'm finding more and more capacitors. There's actually 5. There's one little one here, 1, 2, 3, 4, and 5. That need to be changed, so I'm going to do my drawing of the board and note down the values and voltages and lead spacing for each capacitor, and then we'll desolder, and I'm going to have to place another order actually. So wait for those new capacitors to arrive, and then we'll put them back in. Actually, taking off that shield wasn't too hard. I do have a good quality desoldering gun, so I was able to just really nicely pull that off without any issues. The crazy thing that could happen here is just pulling off traces off the PCB just because of the high heat needed to melt the solder on the shield, but it actually turned out pretty good. So we'll see how it goes back on, but hopefully shouldn't be a problem. Okay, so after almost a week of waiting, I got the capacitors and put them back in, soldered them in. We got this small one here, and that's 100 micros at 16 volts. And the 4 big ones, 1, 2, 3, and 4 in the corner over there, are 10 micros at 160 volts. So, pretty easy values, but, with all the shipping and everything else, it takes a while. So now comes the part where I dread the most, is putting back the shield, because it needs to be soldered in multiple places, and I gotta use a high power soldering gun maybe, so we'll try that out and make sure everything is soldered nicely. And then I'm gonna try to get the zip tie back up, not the same one of course, but a new one, to hold this PCB to the tube as it came from a factory. So. Or get it as close as possible with the zip tie. Now, the zip tie is probably not needed. This is not going to be shaking left and right all that much, but it's just an extra precaution there to mechanically hold it a little better. So. Alright, so with the shield back on, I wanted to show you how I figured out this zip tie situation, which was a weird zip tie with two ends that match, and sort of a cross zip tie there. So basically I use two standard zip ties, kind of like this, and they're connected on the back near the tube socket. And the way I put it on is that I put the zip tie in first through the holes of the shield and the PCB and through the little hook that's on the tube socket. And then I attach this one on the other end. So now they both sort of are, you know, ready to be basically tied here. The other way around, of course, always the other way around with zip ties. You know, no matter how how you do it, it's gonna be. So basically like that. And it doesn't need a lot of force because you don't want to have this to be, you know, putting force on the tube. You know, the whole thing's a glass structure, so you know, it's just there to hide it mechanically a little bit, so it doesn't fall off. So with that, we're done with the electronics, or should be, you know, unless it doesn't work. And so the next steps is to put the case on, but I'll probably will. I don't know, I'm contemplating. I might try it, you know, just to turn it on with no signal, just to see if anything smokes before I put the back case on, the back plastic on. So, well, let me tell you my troubleshooting story here. I put everything back together, and of course it didn't work. Well, what it did is that I pressed the power button, and it just blinked once, and nothing happened. No high voltage, no power, nothing at all. And so, you know, the LED, the power LED is supposed to stay on, but it didn't. It just blinked, and you can hear a little, you know, click going on. So I figured, well, you know, it could be a lot of things. Maybe the caps I put in wrong, or they're not soldered correctly. So I went through pretty much everything, all the caps, resoldered everything. I even found a loose solder joint up here, resoldered that. Tried again, nothing. And then I figured, maybe some other thing. So I took out the the output high voltage transistor, which you can see here. I took that out and measured it. That was good. Funny enough, that transistor has, you know, it's on a heatsink, but there's no thermal paste or thermal compound between the transistor and the heatsink. So I'm not even sure how that would even work, if any at all, if any heat would even transfer to a heatsink. So I put some high quality thermal paste on there, just to make sure that transistor is gonna stay, you know, working for a long time. So that's gonna be better there. Of course, the transistor being so large and so hard to get out, I had to, some of the PCB traces got a little, I pulled them off, so I had to do a little bit of soldering there to connect everything. And then, you know, that didn't do anything. That didn't improve the situation. So then I looked on the PCB on the other side, and I saw some diodes here. They're burnt. There's some burnt marks, and so like, oh, maybe there's something there. And I measured the diode, and I tell you, it was this little diode right here, this one that was in place on the other side. Measured diode, and it measured 3 ohms on both ends, and it measured the short, basically, almost a short. So I figured, maybe I'll take that out, change it. Maybe that's the problem. You know, looked like it was running hot anyway. So I said, okay, well, I'm not gonna change it with the same diode. I don't even have it. This is a really small, like 2 amp avalanche diode, high speed diode. So I have some UF 5408s, which are also high speed, but you know, a lot more amperage, can handle a lot higher voltage, all that stuff. But they're a lot fatter too, so they don't really fit. The leads don't even fit through on the PCB. So I put them on this side. Looks ugly, but you know, this die will stay cool for sure. Anyway, put them back together, nothing. And then I realized, what if I accidentally just held down the power button, and voila, everything just worked. So basically, after all this, it looks like it's the power switch that is not working. And basically what happens, you press it, and it kind of makes temporary contact, blinks the power LED, and that's it. If you hold it in, it works, and everything's on, high voltage. I can hear the high voltage transformer going. The CRT is, you know, You know, it's black, of course, there's no picture on it, but you know, it looks like it's working, everything's working. No funny noises. So yeah, so all this time, it's going to be a power switch. So now the challenge is going to be see if I can find another power switch, and I really don't want to buy another one of these monitors off of eBay, so I'm not going to spend $100 just for this power switch. So if I find this switch, you know, on the side here, then I'll replace it. If I don't, what I'm going to do is I'm just going to short the contacts here. I'm basically, you know, making sure that the power is always on, and you know, so when you plug in the monitor, the power is going to be on, and that's the way I'm going to have to use it. I really don't want to have other sort of goofy solutions where I install some other type of switch that I retrofit in the front or the back or whatever else. You know, I hate those types of things where people have gone through in the plastic and they've added some other switch or some other goofy thing. So if I can't find the exact same power switch, then it'll be just on all the time. But, you know, with that, you know, that testing, I think we're actually going to be done with this project, and we can move on to the restoring the computer. Just want to show you here, this is the transistor that I took out and then put back in with thermal paste, just for reference. It's the output high voltage transistor, and the way this is on there, there's a little metal clip that holds it on. There's not even a screw. So you can imagine that without a thermal compound, no screw, just a metal clip, probably this heatsink was almost useless. So I put some high quality thermal compound on there. You can almost see it here on the edge there. And so this transistor now will last for a long time, hopefully. So that's that. The other area we talked about where I saw burn marks on the PCB is this area here. This is where that diode was, and this is where the new diode is on the back side of the PCB. So I don't know how easy it is to tell, but there's definitely a darkening there of the PCB. It means that there's lots of heat, you know, coming from that diode. So, you know, that's all the stuff I've changed or looked at, and then, you know, the switches right there, right here, and you know, it's gonna be an interesting one for me to figure out what kind of switch this is. It's also, you know, it's installed really well in there, so you know, it's soldered in and twisted and all that. So just desoldering that will be a challenge on its own, even with the desoldering gun. But it's definitely, it sounds good, but it is not working. It sounds like it should be working, but it isn't. So anyway, so that's gonna be, we'll try to figure that out. Well, I decided to actually change the switch here and put in this switch, which I found at the store. It's a much nicer switch than the previous one. This is a 6 amp switch, and you know, I think it's going to be way more reliable. I read that these switches that came with the monitor they often break. And I did find some online, some replicas online, but you know, I didn't feel comfortable changing them to the same switch. Plus, they cost like $50 to ship in high quantities and all that kind of stuff. So I said, forget that. So I looked up a higher amperage rated switch that should last a little longer. Of course, it doesn't fit correctly, so I've done a little bit of, you know, retrofitting here, where you know, the wires are hooked. I added some wires that go into the PCB here. And then I add a little stand, you can see it here, to kind of raise it to the same level. And then finally I glued it a little bit and added a zip tie too, just for extra support, since it doesn't have any sort of support pins or anything like that. So, and a tiny bit of glue on the top there, so that should hold it there for good. And so the action on it is a little bit different. It doesn't have the same click, but it will do the job. So, and it has the same length. So I measured the distance here to be exactly the same. So with that we should be all set to start putting this together and see if it works. All right, so let's give it the ultimate test. My monitor electronics are back together, hooked up, except for the back of the monitor is not on there yet, just because I might need to take it apart again. But against my better judgment, I also hooked up the Mac to it, which I was contemplating should I turn on or not, but you know, I'll turn it on and see. I'm not going to leave it on for a long while just in case there's some backup apps in there, but at least it should work enough to give a signal on the screen. And of course I have the keyboard that we just saw restored in a previous video hooked up as well. Given that these Macs are turned, the power's turned on by the keyboard button there, so I kind of need that for it to function. So first thing, the switch. Press the switch. Looks good. Green light is on steady, which is what we want. And then second thing is the Mac. Let's see what happens here. Okay. There it is, finally. Hard drive's dead, I can already tell. But it should show something. It's trying hard with the hard drive, trying hard. But there it is. We have welcome to Macintosh. Well, maybe the hard drive does work. It's amazing if it actually does. Look at that. And the screen works as well. So what I might do here is to get the screen to be a tiny bit bigger. You know, this is the factory size, but I might try to adjust it just a little bit to fill the screen just a little bit. And so, yeah. So I call this a success, except for the whiny hard drive, which will be next in our restoration work here. And you know, we'll move on to the computer. And here's everything that came out of the monitor. All the capacitors. This one, remember, is the 6.8 microfarad non-polarized one. You got the little diode here that took out, which probably didn't need to be strictly taken out, but it was heating up and so it needed to go. And of course the faulty switch as well. So all the stuff. Now you may say, well, some of these capacitors might be still good, and you're right, they might be good. They might be good for a couple more years, or maybe even 10 years or 20 years. But, you know, once you get something apart, why take the risk of leaving some of them in and some of them not? And so, you know, then you say, okay, well, maybe the device will work for another 5 years or so. And then you never know when one of these capacitors will go bad and pop in and take a whole bunch of stuff out with it, right? So, you know, once these go bad and short or, you know, bulge up, and you cannot see any bulging here on these, but, you know, once that happens, then it's game over for, you know, even components around the capacitors, diodes and things like that. So, yeah, so there it is, a big pile of caps coming out of the monitor. So now I feel good that, you know, this monitor will probably last for probably another 30 years. You know, like if the tube might go bad, you know, make them leaky or whatever, but hopefully it won't. But other than that, everything else should be okay in there. Well, we reached the end of this video. Thanks for watching me go through and restore this Apple Performa Plus monitor. You know, it took longer than I thought it would. Sometimes these restorations are easy, sometimes they're more difficult. If things are broken or seem broken, like in this case, and trying to troubleshoot and see what's wrong. So thanks for bearing with me, and hopefully you learned something from the process of what it takes to restore you know, such a piece of electronics. So yeah, so I'm looking forward to restoring now the actual Mac itself, and that's going to be interesting in its own right, since there's going to be surface mount components there. So we'll have to take a look at those and see if those need to be changed. So that's going to be fun. But anyway, thanks for watching, and let me know if you have any comments below. Happy to answer them, and see you next time.